Hello guys, in this lesson we are trying to create or drive the shape parameter and the material selection factor to be created for what? The system parameters like the inertia or the mass or the radius factor of this wheel. Okay, and so we need to start with the wheel shape. Okay, wheel shape is in the 3D dimension like this one. Okay, and so the area of this wheel can be calculated by what? The A is equal to the 2 PR, which is the circumference of this wheel, times D, because this term is equal to the D, or the width of this shape or the wheel shape is equal to the D. Okay, we can assign it, and so J is equal to the what? Is equal to the 1 divided by 2 times M times R square, because we have the radius factor like this one. Okay, and so the M is also can be calculated by the rho, which is the density factor of this wheel, which is dependent on the material selection factor, and P times R square, which is the area of this wheel like this one, and so we need to times D, because this parameter gives us the volume value of this wheel, and so rho is equal to the density factor, and so the density times volume gives us a mass factor like this one. Okay, and so how can we use the area factor of these things? Area in the final form can be derived by the C parameter calculation. C is the damping ratio of these things, and so CD is the direct force of the air friction on this wheel shape, and so we need to create the model to represent the C or the damping ratio by multiplying the CD direct force coefficient times A factor in here. Okay, and so if we write the whole equation in the final form, we get the torque value times or equals to x dot dot times, in this term we need to create the M times R plus J divided by R, and so which gives us the rho times P times R square times D. This is the mass factor times R, plus J term should be included in here, and so 1 divided by 2 times M should be added like this one, and so P rho times P times R square times D and times R. Okay, because we have this kind of form in here. Okay, and so we need to write also the friction factor of this system like this one. X dot is equal to the what? The C value in here, and so 2 PR D times CD. Okay, and so in the last form, if we reorganize the whole equation of motion in here, and then x dot dot should be equal to the what? Equal to the rho times P times R over 3 times D plus 1 divided by 2 times rho times P times R square times D. Okay, because the M is in here, and so we need to also create these things. Okay, And what about the second term of these things, x dot times 2 times P times D R square, because A come from here, and so we need to multiply the equation, the R, in order to convert this force value into the torque, and so we need to also add the CD value as a drag force coefficients. Okay, and so we can summarize the system parameter like this one, I AC and C AC in here. In the final form, we can write the whole equation in the simple form like this one. Torque must be equal to the what? I AC times X dot dot plus X dot times C AC. Okay, this is our general form of this wheel model. Okay, and so finally we can continue with the PID controller design with the basis of the transfer function algorithm, because the transfer function can be applied on the linear systems, and so we can use the transfer function method by taking the Laplace transform of these things, and so we can design the PID controller, proportional, integral and derivative controller, but with one basic difference, which is the reference tracking must be satisfied on this PID controller. Okay, in the next lesson we will discuss about it.